In this video, we're going to be looking at chemical and physical changes and how they are different. The key point with a physical change is no new substance is created. So it has the same chemical formula as before. So some common examples of physical changes are boiling water. When you boil water, you have water as a liquid, and it's turned into water as a gas. It still has the same chemical formula. Another type of chemical change is ripping up paper. When you rip up paper, it's still paper. It's just smaller pieces of paper. Another example of a chemical change is when your parents possibly chop up wood. It's still wood, it's just smaller pieces. Another example is when you dissolve some salt into your soup. So the sodium chloride starts as a solid and it ends up in solution. So we say it's aqueous. But in both cases, in all of these cases, the formula stays the same. No new substance is created. So here's an example of a change of state, and changes of state are often reversible. So your solid can go to a liquid, liquid can go to a gas, gas can go back to a solid, and they're all reversible stages. But in each of these cases, this is still water, this is still water, and this is still water, has the same formula. No new substance is created. Some physical changes aren't reversible. For example, breaking a window. When you break a window, it's hard to put the window back together. Now, chemical changes, you get a new substance created. It has to obey the conservation of mass, and that says that matter can be changed from one form to another, but it must be conserved. So if you started with 50 grams of a reactant, you will finish with 50 grams of a product. Now, most chemical changes are really hard to reverse. So this is an example of a chemical change. You'll notice you start with a raw egg. It looks different. This is clear. And here, after the chemical change, this is white. So you can see there are very distinct changes. The chemical formulas of these proteins in the eggs have changed. Now, there are many indicators of a chemical change. A precipitate. This is when a solid falls out of solution. So you make a solid from two solutions and it tends to fall out. You're probably most familiar with the word precipitation when we're talking about rain, and there we have a liquid falling out of a gas. With chemistry, we talk about a precipitate as a solid falling out of a solution. Now, you might get an odour, and this is most likely if you form a gas. Sometimes you see bubbles, and once again, this tells you that you probably made a gas. Often you can have a change of temperature. Sometimes it gets hotter and sometimes it gets colder. Sometimes you get light emitted. Sometimes you get a change in colour. And sometimes the substance disappears. So all of these are indicators that a chemical change has taken place. Both physical and chemical changes can be described using an equation, and they are always written in the format of reactants versus products. These equations must obey the law of conservation of mass, or matter, and this says that matter cannot be created nor destroyed. It can only be changed from one form to another. So this means, as a consequence, you have the same number of atoms on the reactant side as the product side. And to do that, we must balance. So an example would be sodium chloride, add silver nitrate, gives you silver chloride plus sodium nitrate. And if you look at this, we've got the same number of sodium atoms, 1 and 1, the same number of chlorine atoms, 1 and 1, same number of silver atoms, 1 and 1, same number of nitrogen atoms, 1 and 1, and the same number of oxygen atoms, 3 and 3. And to make it work, we have to use something called balancing, and that's in Year 9 chemistry. So that'll be something exciting that you learn about next year. Okay, I hope you've learnt something about physical and chemical changes. Now you get to watch a video of Miss Hauge and myself doing some physical and chemical changes.